Okay, I'm going to give a brief tour of the B Research S.T.A.R fusion reactor Mark IV. To start off with, here we have a vacuum system. You can see here the roughing pump. Then we have a valve between the roughing pump and a vacuum reservoir. We have a big dial on the reservoir, and we also have a Pirani gauge. The vacuum reservoir goes to the turbo pump. Okay, the turbo pump is connected via a gate valve and goes into a thermocouple gauge, then into a short bellows hose and into a solid vacuum pipe, which then goes into the S.T.A.R reactor itself. The S.T.A.R reactor itself is built in a plastic or acrylic tank and is filled with dielectric oil. It is concentric spherical cathode and anode, and it's connected up through a stainless steel nipple with a viewport to the ion gun. The ion gun is connected to a bleed valve, which goes to a solenoid valve, then through a ball valve and to the deuterium gas cylinder, which is regulated. The ion gun is connected to a power supply and has a voltage gauge and an amp gauge. The power supply for the heater on the ion gun is a large plating rectifier capable of 10 volts and 50 amps. Going up here, the ion gun bias comes from a single phase rectified MOT, which is in turn connected to a variac. The S.T.A.R reactor, as you can see, is constructed in an acrylic cylinder, which is a rubber seal at the bottom and a rubber seal at the top. Because this reactor is immersed in dielectric oil, there's no need for a high voltage feed through. So we have a coaxial high voltage cable that feeds directly into the dielectric oil via a metal flange and a banana jack that plugs into the cathode at the other end. The high voltage cable is connected into the main power supply, which is a gamma high voltage power supply capable of 100 kilovolts at 5 milliamps. There's a warning light that flashes on top of that when the high voltage power is switched on. Next, adjacent to that is a video camera, which during operation films the accelerator tube and through the viewport in the ion gun. The fusion reactor can be remotely controlled, as you can see the cables here, via my remote control station here, which is a lead shielded panel. And here I have control of the power supply and of the vacuum pressure, and I also have a Geiger counter here indicating any X-ray emission from the fusion reactor itself. To the side here we have a television monitor that we can monitor the ion gun and the activity in the accelerator tube.